Hello everyone, in this video I'll be explaining the unsaturated hydrocarbons, that is alkynes. Now in the previous videos we have discussed the alkanes, the carbon-to-carbon single bond, the saturated hydrocarbons, and then the alkynes, carbon-to-carbon double bond. Therefore, the third type of hydrocarbons is our alkynes, that is carbon-to-carbon triple bond. Alkynes have carbon-to-carbon triple bond, and carbon atom is sp2 hybridized, where S character is also 50% and P character is also of 50%. Now, alkynes, they have a linear structure. Alkynes have a linear structure, and the general formula of alkynes is CnH2n minus 2. Now, let's take. In alkynes, there are two pi bonds and one sigma bonds. That is, two of the bonds are formed by pi bonds and one bond is formed by sigma bonds. Now, if we check the structure, first acetylene, that is carbon-to-carbon double bond, triple bond. This is our acetylene molecule. Now, this is carbon, another carbon atom, carbon. There are 4 orbitals here. Now it bonds with hydrogen here. Now this is our py, this is also our py, pz orbital, pz, py, py, pz, pz, and then this will be our px, and then px. This is formed by hydrogen. Now this, the sp orbital, all of these are sp orbitals. All the sigma bond is formed here. Now the py orbitals and the pz, there's overlapping occurs, and pi bond is formed, and then here also a pi bond is formed. Therefore, in alkynes, the carbon-to-carbon triple bond, there are 2 pi bonds and 1 sigma bond. Now let's check the preparation methods. The preparation methods of alkynes. How are alkynes prepared? Now, the first method is from calcium carbide. Now, from calcium carbide, what is our calcium carbide? Is calcium CaC2. Now, the structure for calcium carbide is Ca2 plus, and then the carbide is carbon having negative charge to neutralize the Ca2. Now, from calcium carbide, how is it prepared? On large industrial scale, ethylene is prepared by treating calcium carbide with water. Therefore, now how does calcium carbide react with water? In the calcium carbide here, this is our calcium carbide. Okay, if we just take here we have 2 minus, and then if it reacts with 2 moles of water. Now if it reacts with 2 moles, there is removal of calcium hydroxide. Now this 2H along with the calcium is removed. Therefore, we'll be getting carbon-to-carbon triple bond, the carbon-to-carbon triple bond, and then the 2H hydrogen would come here, it takes here, bond form here. Therefore, in this way, alkynes are formed. Now, second preparation. The second preparation method is from vicinal dihalides. Now, what are vicinal dihalides means? Vicinal dihalides means the halides are bonded to different carbon atoms. Now, this one chlorine, this is a vicinal dihalide. The halogen atoms are bonded to different carbon atoms. Now, if it reacts with alcoholic potassium hydroxide, alcoholic potassium hydroxide, there is removal of HCl. HCl is removed from this base. Now, alcoholic, if it reacts with call it potassium hydroxide, and then we'll be getting here H. This would go up here, so carbon to carbon double bond C, H, H, and then our Cl, one Cl would remain here. Therefore, now I can soda amide it reacts the alkene. This is an alkene. The alkene form reacts with soda amide. Now, if it reacts with soda amide, what will be our product here? Now, if it reacts with soda amide, there is removal of NaCl is removed along with ammonia. NaCl, this is the plus group, this is the minus group, this is the plus group, and this is the minus group. This Na plus would take this chlorine away with it, and then this one, and then the NH2 comes and takes this H plus, and then with there's removal of ammonia molecule. Therefore, we'll be getting, and this bond would come here. Therefore, we'll be getting our carbon to carbon triple bond in this way. So, these are the two methods in which alkynes are prepared. The first one is from calcium carbide. The second one is from vinyl dihalides. Now, if we check the physical properties of alkynes, it is seen that the first three alkyne studies, ethyne, propyne, and butane, the first three alkynes, they are gases. They are gases, and then from carbon number 4 to carbon number 8 are liquid, and the higher alkynes are solid. Now, ethyne has a characteristic smell of garlic, the garlic that we use in our daily curries, most of the curries. The ethyne has a characteristic garlic smell. Only ethyne has a smell, and all the remaining alkynes have no smell. That is, they are odorless, and only ethyne has an odor. Now, alkynes are weakly polar. They are weakly polar and lighter than water, and are soluble only in organic solvents like benzene, CCl4, and ethers. Now, the alkynes have higher boiling points. The alkynes they have higher boiling points than the alkenes, the carbon to carbon double bond or the single bond. Because now, why is it so? If we consider the boiling point here, now, as I've said in the starting part of this video, that in alkynes the carbon is sp2 hybridized. Therefore, the carbon is S character is also 50% and P character is also 50%. Then therefore, and we know that there is a linear structure for alkynes. Therefore, these are the two properties that makes alkynes have higher boiling points than as compared to that of alkenes, the carbon to carbon double bond, and the carbon to carbon single bond alkenes. In the next videos, I'll be discussing the chemical properties of alkynes.